510. Transforming litter. I'm sorry. Start over, shall we? Because it's 510. Transforming linear functions. So linear is just line functions. We talked about. Basically, we're just looking at taking lines and moving them around. So reflecting them, moving them. It's not a big deal. Yes, sir. Roman numeral 1 is terms. Roman numeral 1. Yes. So family of functions. So you and your family, you're all related to each other in some way, shape, or form. That if you have a family of functions, so if you have a group of lines that are all going to be like related to each other in some way. So it's a set of functions. In this chapter, it's all going to be lines. So a set of functions with the same basic characteristics. And we'll see what this means more soon. If you have, like, in your family, kind of, people say that my kids look like either Michelle or I, because we're the parents. That's going to kind of be the ones that set the blueprint, so to speak. A parent function in math is going to be similar. It's like the original one. So the parent function is the most basic function. And I think that this can be a little bit screwy in some ways. I want to like put equations on one side and like a graph on the other. But if I were to have a graph, and if I'm going to pick a line that goes up on some sort of an angle through the origin, so something like this. And if I'm going to draw one parallel to it but down a little bit, and then one up above it, it's parallel to it, something like that. Actually, I'm going to make that one up above a little bit higher, but it doesn't really matter if yours isn't. Yours is equally spaced, but something like that. If I have those three lines, I was aiming for straight. Can you tell which one is going to have the most basic function, or most basic equation? The one through the origin. So it has a y-intercept of 0. So they're going to call that one the parent function. I'll maybe try to label that middle one like f of x. And I'm going to make up an equation that looks halfway decent for mine. But f of x then, maybe I'm just going to call, slope is a little less than 1, it looks like. So maybe I'll say is like 2/3 x. So f of x, or y, is 2/3 x for that one. The one that's down below it, maybe I could call that one g of x. What do I know about the slope of g of x? Perfect, it's the same. It has to be 2/3. So g of x will equal 2/3 x. But now what has to go after that 2/3 x? It has to be that number after it. So it's kind of a bad question because we don't know what that number is. But if this number were like a -3, this would be 2/3 x minus 3 because the y-intercept is a -3. Good. And then maybe, what other option do I have? We'll pick a yellowish. So if I then say h of x. H of x, who could give me a reasonable approximation for h of x? H of x is going to be, okay, so it looks like it's about up 6, up 5 or up 6, so 2/3 x, but now it has a y-intercept of plus 6, something like that. Where for that, we could say then the parent function is going to be this one here. It's the parent. It's the most basic. It's the easiest equation. Something like that. Feel okay for those? Then one more term, and then we'll jump over to some other things. So my second thing third I want to say is transformation. In doing this before, I found that a lot of people confuse the words transformation and translation. So kind of keep those two separate in your brain. But a transformation is going to be a change in position or size of an object. So change in position or the size of an object. So in other words, if I started with that original function, the f of x, if I did a transformation to it, I could slide it down to give me that g of x. That's a transformation. I could slide it up to give me the h of x. I could take and rotate it around, which then would give me a different facing line type of thing. But basically, a transformation just takes a parent function, an original, and moves it into some other position, or rotates it, or reflects it, or something like that. And our second part of the notes, Roman numeral 2, is just going to go through and do like some examples, some different types of that. So types of transformations. You guys maybe grew up right in between when Transformers came out originally, and maybe they weren't there when you were a kid. I know for my son, he's kind of hitting that a little bit. But Transformers are transforming from one thing to another, right? A transformation is just taking the line or taking the function and changing it to something else. So I want to go through and do some different types of these. So the first one is going to be a translation. And that was that word that I said a lot of people confuse with a transformation. So a translation is a type of transformation, a type of being transformed. But it's just moving the thing around. A lot of times they refer to it as like sliding. So sliding all the points on a graph the same distance and direction. So the example we were doing before is going to be an example of one of those translations. So this here, you could look at it as though we slid that blue line up and down. So that's going to be a translation. If you wanted to quick redraw it, you could say something like, here's my line. I'm going to take and move all my objects down. Or you could move it to the right or something like that. But that there would be your translation. Okay, and translations? My second type is going to be a rotation. So number 2, rotation. So rotation is turning an object around a point. So turning an object around a point. Often for starting out, the point is going to be the origin, just because it's a lot easier equation-wise for that. So for that, you could have maybe like, here's my original. We're going to take and kind of rotate it. I'll just kind of do it around kind of like the midpoint. But then the new one, maybe I'll do the new one as like a dashed line. You could do solid if you wanted to. Maybe I should have done my other one as like a dashed line here or something. But trying to show which one's the parent function. But it just turns it. Work for you? For example, then, maybe I should have done this here, that this one would be f of x, and say that's a x plus 2. So a slope of 1, I maybe should have done like 1/2 x plus 2 or something like that. But now my second one down here could be g of x. You agree it at least has a larger slope. So maybe then I could say like a 8x plus 2. So then this point right there would have to be the 2. That doesn't really matter. But at least you can see it changes the slope when you rotate something. Where if I were to go back to this one, if my original was a f of x, just say f of x equals x. Now g of x is just a fancy way of saying y, right? We just made it lower. So could I convince you if we make it lower, it'll be something like a x minus 3? Just take all those x values and you take some away from it to make the y be 3 lower. Good? First two? Cool. Then the third kind is going to be a reflection. So 3 is a reflection. And reflection is, I think of the verb flip. So it's flipping an object over a line. Usually it'll be like the x-axis or the y-axis or this diagonal line, y equals x. In our chapter, it's always the y-axis. So when they have one like this, maybe I'll quick draw in like a graph. If I do like my coordinate plane. And now if I have a equation, maybe I'll say this here, I'll call this f of x. It looks like that is a slope of 1, so I'll just say f of x equals 1x, or f of x equals x. If we take and flip that thing, I'm going to say, all right, now we're taking this and flipping it this way and that way. It's going to give me a new one, which would come down this way. That right there is going to be my new function. I'll call that g of x. Can anybody think of the equation? It's tough, but I think you'll get it. So then this here would be a negative x, or a negative 1x. Nicely done. Good thinking. But for this chapter, it's always going to be a reflection across the y-axis. Questions on those three before I hit the last chunk? Then the very last thing, I'm going to say, it is possible to do multiple transformations. So it's possible to do multiple transformations. In other words, you could first take something and slide it up, and then after that you could take and reflect it across the y-axis or something like that. And I'm just going to do an example here, and we'll kind of call it good from there. So I'm going to say example, what transformations are needed to change? So what transformations to change? I'm going to say f of x equals x into g of x equals 3x plus 2. So for that we really have two things. We change the slope and we change the y-intercept. Agreed? So which one of these three changed the slope? Apparently I can't get a slide up and down now. Oh, there it is. So which one changed the slope? Rotation. So the first thing is going to be a rotation. And then the second thing, what changes that y-intercept? The translation. So then for this, we could just say, well, what changes the slope? So then I had my x, my 1x changed into a 3x. So I'm going to say x into 3x is kind of what I'm talking about. So that's going to be a rotation. So we know at some point that function was rotated. Then that second one, what changes height? And that's where I had my, maybe I'll just say the plus 2. So that then would have to be the translation. The slide or the moving something. Any questions?